Hey everyone, just wanted to cover verifying fire flows with you all. This is chapter 11, and what we'll do is we'll work through it together. That way you guys can have a fairly good understanding of it, as providing I instruct it fairly well for you. We'll start off by me reading the scenario, and then we'll kind of talk about the assignment and kind of go through the documents that are with it and kind of make sure we all understand it. Okay. The scenario is, as the inspector, the candidate has been presented with the floor plan for a new banquet center, the enclosed documentation of fire flow tests. The candidate shall determine the available fire flow from the flow tests and the required fire flow for the facility. Identify all deficiencies, document those deficiencies, and make recommendations to remedy the deficiencies in compliance with applicable codes and policies. The candidate shall thoroughly complete the required documentation for the fire flow for the occupancy. All right. Kind of a confusing skill. That's why I kind of want to go over it with everyone. You basically are given some data that you'll end up using, or some tables. So let's go over those tables first and kind of go over the problem itself. Okay. The first one you come across is this minimum required fire flow and flow duration for buildings. You're going to be needing it. You're also going to need this number and distribution of fire hydrants table. They provide you with the layout or the floor plan of the banquet hall, and they also provide you with some information down here, or as far as the type of construction, the non-sprinklered, and then your test results. Okay, those are all going to be really important. Okay, so the first thing that we need to do is look at this next piece of paper, and basically it's the one that we're going to be writing all of our answers on. So this is your answer sheet. This is what everything's going to be going on that you're going to determine. Okay, and a lot of it is just pretty straight, simple, forward stuff. It really doesn't get really confusing at all until we get up here to the chart, and we'll go over the chart together as a group. Okay, I'm going to move this camera just a little bit. Let's see if I can get it. All right, leveled out for you guys. All right, first of all, we're going to look at determining the building area. That's a pretty simple thing for us to do. Just the length times the width. For this scenario, it's a 200 by a, so it's a 200 by 250 foot building. Which gives us how many square feet? It's a pretty easy thing to do, just length times width, and that is 50,000 square feet. So I'll write that in here. All right, I'm pretty bright red there so you guys can all see it. The next thing we need to know is to determine the fire flow required for the building without sprinklers. Now, for us to do that, we need to get to that chart B105.1. That's this one here. Pull this up a little bit. Okay. And we know how many square feet we have. And from the information they gave us, we know it's a type 2A construction. So we're going to look at type 2A. We're going to go down to 50,000 square feet. And we're going to go straight across. And we're going to look at the fire flow gallons per minute. And we think you guys can all see that it's 3250. Let me just circle that there. 3250. Make sure you don't get confused by any of the other columns, but that's the one you're needing, the 3250 for the 50,000 square foot type 2A. So we know that, and we can write that in our answers here, right? So we get to that, and we'll write down the 3,250 gallons per minute, right? All right, good job, everyone. We're flying right along here. Okay. The next thing, or next question, is the number of hydrants that's going to be required. That's the number of hydrants required for the fire flow. Now, in order to figure that one out, we need to look at just some simple calculations. One hydrant, by your reading and by the standard, can flow 1,000 gallons per minute. Well, we need 3,250 gallons per minute. So we're not going to be able to round down. We always round up on that one. Okay, so we're able to look at this chart again, look at the different chart, the 105.1. There's not a 3250 on there, so we're rounding up to the 3,500, and that gives us how many? 4 fire hydrants. So we're always going to be rounding up. So 1,000 gallons per minute, 3,250, that's going to give you the 4 fire hydrants. Again, so far so good. It's pretty straightforward, okay? The next question, though, is the fire flow required for a building with sprinklers. Okay, so on that one, we should know from our reading that a sprinkler system will reduce the need by 75%. So we only need 25% of the needed water. So we're able to calculate that by 3,250 times 25%, because we only need 25%. If we can reduce it by 75, that leaves us with 25. That leaves us with 812.5 gallons per minute. But, and here's the caveat for all this, there is a minimum required by NFPA of 1,500 gallons per minute. So that's our real answer for a minimum, okay? So the minimum is actually 1,500 gallons per minute. I'll put that in here because that is the minimum amount we can put due to the NFPA standards, right? Okay, and that was in your reading and text as well, so don't worry about that. It is in there. Hopefully you guys caught that. So even though when we reduced it with the sprinkler system down to the 812 gallons per minute, we still, that's the minimum we can do is 1,500. So that's all we can do. Now, when we start looking at the number of fire hydrants required for that fire flow, we go back to that same chart. Now, earlier, I told you that we needed the 4 in order to flow the 3,200 because we had to round up. However, on the 1,750 or less, it doesn't make us round up. So the 1,500 gallons, we can flow with just the 1 hydrant, okay? That to me is confusing, but that's the answer. It's just 1. So we just need the 1 hydrant to flow the 1,500 gallons per minute. So right now we've already got our first 5 answers. So it's pretty simple, you would think. We only have 1 answer left, but it's the most complicated one, and it has to do with this chart that we're going to have to do, okay? So let me kind of get stuff situated here, and we'll kind of go over that. In order to determine that flow determination, the book gives you a set of directions. And the first thing they tell you to do is to determine which scale to use. Well, the only problem I find with that is that's the hardest thing for me to determine is what scale to use. And the way they do that is we're going to look back up here and we're looking at these hydrants. How much water did we flow out of them? So during the testing of them, we were able to flow 1,650 gallons per minute. Gallons per minute. So that is going to help us tell us which scale to use. The way to choose the scale is later on you're going to have to make a line, and the line has to go through a couple different points, and it has to go down to the 20 psi mark. So you want to try to move the scale out as far as you can. I know that's complicated because 1650 is actually on here twice. It's actually on scale B way out here, and it's actually on scale C way at the very beginning. Well, we want to stretch it out as far as we can, so we're going to use scale B, and we'll write that right there. That way we know what scale we're going to use, okay? The next thing we need to do is locate and plot on the static pressure, locate the static pressure on the vertical scale, okay? So what they mean by that is we know that our static pressure is 75 psi, right? So we're going to go up the 0 scale. This is the 0 scale, and mark 75 psi by just making a dot. Okay. So we've made our first dot on there. The next thing we're going to do is that we're going to locate the total water flow measured during the test on the chart. Well, we did that earlier. It was the 1650 I talked to you guys about already, the 1650. And we're going to go over to the 1650 marker on that scale B, which is right about here somewhere. Okay, right about there. All right. And then we're going to locate the residual pressure noted during the test on the chart. So we'll go back to our given stuff. The residual pressure was given to us at 34 psi. Okay, so that is what our residual pressure is. We're going to basically take that residual pressure, find it over here on the scale 34, and go straight over to where our 1650 would be. So it's going to be right about there. Let's just make a dot right there. All right. Now we're going to end up making a straight line. So you're going to have some kind of ruler of some sort. So you can draw a straight line, okay? And what you're going to do is you're going to take a straight line and draw it straight through those dots, all the way through the scale, just like that, okay? So now you have the line all the way through, all right? After that, you need to read the gallons per minute available at 20 PSI. Does anyone remember why 20 PSI is so important? That's the residual pressure that we need to maintain so we don't get sediment backflowing into the water supply system. So we'll find the 20 on here and we'll go straight across and see where it intersects the line, okay? It intersects the line right about there. We can go then down to the scale to see what it falls under right about just off of the line. And it's really hard to tell on the scales like this. It's right around 1900 gallons per minute. It's right around right there. It's 19, it's between the 18 and the 2000 on scale B. So it's around 1900 gallons per minute. And that's our answer for the fire flow determined from the flow test. So this determines our fire flow. Okay, based on that residual pressure of 20 right there. Here's your 34. Like that. All right. Clear as mud, isn't it? It's a rather confusing, and to be honest, no one uses these anymore. You can actually put the same data that you've gotten here into a simple calculator that you can find anywhere on the internet, and it'll calculate all this for you. It's super simple. So we really don't have to calculate these anymore, but we still will need to know how. But for the most part, we don't do them a whole lot anymore. There is a level 1 inspector skill, so we do need to understand it. We'll work through some more of these if you want. If anyone has any questions, they can always get a hold of me and we'll work through some more of them. But I wanted to make sure you guys were able to see one. All right, if you guys have any questions, you know how to get a hold of me.